Okay, so how is this implemented? Well, so the good news about doing DynamoDB is that you have a Python class, and basically each class member represents either a field or an index, and then in your table, they're basically defining the column headers here, and then there's a nested class called meta, and you have an ability to set a host parameter and set it to local, which is what I did for running all this. And then in the query method, elsewhere in the same file, it's not really a part of that data definition there, but we basically we connect and we set a condition, and then we do the response. And this is some of the most painful code of my life, really, because this condition equals number attribute is a class, and then that is less than or equal to the criteria, and that is just the strangest little way to write it, because all of this Python gets boiled down into a set of JSON that is shot up to your DynamoDB server for execution. DynamoDB, the local is an executable jar, so I'm sure that it's a Java 2 Enterprise Edition system, and you're programming it in JSON, and it must be dynamically cooking an awful lot of stuff. To make the coding experience more like Python, you have this is using an awful lot of the Python class machinery to, when you instantiate these things, it is parsing and munging and doing all kinds of wild stuff. And then I had to get down into the lower level API to figure out just how to run this query and actually get it to work, because it was tearing me up. We're doing a rate limited scan, but the class approach at the higher level API just is not complete at this time. So we take this back, and it's a list comprehension, because when you say rate limited scan here, it's a generator. And so you want to pull that generator's values out in a list comprehension. So we're getting response is going to be a list of values that came back, and then we can take those and make a frozen set out of them for our later comparisons.